hidden all around us. A single shape lies at the core of navigation, architecture, and calculus: triangles. Triangles are intertwined in the most infuriating and arcane branch of mathematics, trigonometry. What are the fundamental concepts behind trigonometry? Angles and sides. Trigonometry is all about the study of angles and sides, which are both concepts that you would have encountered in elementary school math. But fundamentally, what are they? A vertex of a shape is the point at which two line segments meet, essentially the corner of a shape. The lines that connect at vertices are called sides. For the purposes of this video, remember that a triangle has 3 sides and 3 vertices. An angle is the measurement of how wide the space between two sides of a polygon is, measured in degrees or radians. 180 degrees is said to be the angle of a straight line, while 360 degrees is said to be the maximum possible angle around a circle. Angles in standard position are drawn in the Cartesian plane between two rays. The rays are centered on the origin point, 0, 0, and one ray is fixed exactly on the positive x-axis, called the initial side, while the other ray, called the terminal side, rotates around in the counterclockwise direction. Any angle n that is greater than 360 degrees is equal to n minus 360 degrees times m, where m is a positive integer and n minus 360 degrees times m is greater than or equal to 0, but less than or equal to 360 degrees. Meanwhile, any angle L that is less than 0 degrees is equal to 360 degrees times m plus L, where m is a positive integer. Radians are another measurement of angles which help measure angles with real numbers. 1 radian is said to be the measure of the angle inside a sector, of which the arc length is equal to the radius of a circle. In simple terms, the angle of a straight line is pi radians, while the maximum angle is 2 pi radians. To convert from radians to degrees, you simply multiply the measurement by 180 degrees over pi, while you multiply the reciprocal to convert in the opposite direction. Special angles. There are 2 triangles that require special attention in trigonometry. While we will dive deep into calculations and explanations, note that we will only cover right-angled triangles in this video. The first is an isosceles right-angled triangle. This triangle has 2 bases of equal lengths, and one long side called the hypotenuse. The right angle lies opposite of the hypotenuse, while the 2 45-degree angles lie opposite of the 2 equal bases. This is well known to most people. Interestingly, the sides of this triangle follow a specific pattern, regardless of its size. The ratio of the length of a base to the length of the hypotenuse will always be 1 to root 2, which also follows the Pythagorean theorem. Meanwhile, the other special triangle contains angles of 30 degrees, 60 degrees, 90 degrees, which contains side lengths of 1 to root 3 to 2, respectively. Trigonometric functions. There are 3 basic trigonometric functions: the sine, the cosine, and the tangent. There are reciprocal functions of each, being the cosecant, the secant, and the cotangent respectively. Let's try to understand what these mean. Take a right triangle ABC, with angle B being the right angle A being A degrees, angle C being C degrees, side AB being X units, side BC being Y units, side AC, the hypotenuse, being Z units long. Trigonometric functions return different values depending on the chosen angle. We will choose angle A. All trigonometric functions are ratios of the lengths of the sides, which are interestingly fixed for different angles. The sine function returns the length of the side opposite to a given angle over the length of the hypotenuse. The cosine function returns the length of the side adjacent to a given angle over the length of the hypotenuse, while the tangent function returns the length of the opposite side over the adjacent side. So the sine of A is, therefore, y over z, since BC is the side opposite to angle A. The cosine of A is x over z, while the tangent of A is y over x, which is also equal to sine A over cosine A. The reciprocal functions return reciprocal values for each, respectively. Conversely, there exist three inverse trigonometric functions, known as the inverse sine or arcsine, inverse cosine or arccosine, and inverse tangent or arctangent, respectively. The inverse trigonometric functions require a ratio of sides as an input and returns the value of the angle between the two sides as an output. But why is this so important? After all, these aren't the only ratios that exist in maths. To understand their gravity, let's apply the functions in real life. Take an isosceles right triangle with base length of x and hypotenuse of length x times root 2. We'll use this 45 degrees angle as a reference frame. The sine of this angle will be x over x times root 2, which simplifies to 1 over root 2, which can be rationalized into root 2 over 2. So the sine of 45 degrees is root 2 over 2, or approximately 0.7071. Since the two bases are the same length, the cosine will also be root 2 over 2. The tangent of 45 degrees will be x over x, or 1. The magical elegance of trigonometry is that, regardless of what value we assign to x, as long as x is greater than 0, the ratio of the sides will always be the same. Base lengths of isosceles triangles will always have a ratio of 1 to 1, while the length of a base will always be approximately 0.7071 times the length of the hypotenuse. Even more importantly, the angle formed between two sides of a triangle will be the same for sides that simplify to the same trigonometric ratio. So similar triangles, or triangles with the same angles but not the same side lengths, are fundamentally the same. Applications. This is a warning for viewers turning on subtitles that it may not display mathematical figures. Please refer to the symbols written on the screen instead. Using right-angle trigonometry, let's solve the following problem together. There are two right triangles, ABC and BCD, with right angles at angle ABC and angle BCD. It is given that AC is 55 units long, BD is 150 units long, and angle ACB is 35 degrees. Notice that the figure is not drawn to scale. Given this, find the value of alpha, beta, gamma, x, y, and z. Give any non-terminating answers corrected to four significant figures and represent all angle values in degrees. To find the values in triangle BCD, we first need to obtain all side lengths for angle ABC, as there is a shared side of x. Firstly, the value of alpha is simply 180 degrees minus 90 degrees plus 35 degrees, or 55 degrees, as the two other angle values in the right triangle are given. The values of x and y will have to be solved using trigonometric functions. Cosine 35 degrees is equal to the side adjacent to 35 degrees over the hypotenuse, or x over 55. Rearranging the equation cosine 35 degrees as x over 55, we obtain that 55 times cosine 35 degrees is x. Calculating, x is equal to 45.05, rounded to four significant figures. Sine 35 degrees is equal to the side opposite to 35 degrees over the hypotenuse, y over 55. Rearranging the equation sine 35 degrees is equal to y over 55, we obtain that 55 times sine 35 degrees is equal to y. Thus, y is 31.55. Using the Pythagorean theorem, we can conclude that 150 squared minus x squared is equal to z squared, and z is equal to the square root of 150 squared minus 55 times cosine 35 degrees squared, which is equal to 143.1. To find beta, we will use the inverse cosine function. Beta is equal to the inverse cosine of x over 150, which is equal to 72.52 degrees, rounded to four significant figures. Similarly, we can use the inverse sine function to find the value of gamma. Gamma is equal to the inverse sine of x over 150, which is 17.48 degrees. If you did not figure out these values by yourself, we encourage you to go back through the video and try to solve the problem again. Conclusion. This was the story of right-angled trigonometry, of the sides and angles of right triangles. But wait, what about the law of sines and cosines? Is trigonometry with non-right triangles even possible? Well, Those amazing stories will have to be saved for the next episode on trigonometry.